All right, let's try to figure out how much work Jasmine lifts. So the first thing we have to do is we have to convert everything. So we got to take 130 pounds, and we got to convert that to pounds over here and newtons. All right, we know that 1 pound is going to be equal to 4.448. So we got that right there. All right, and we're solving for x. So all we got to do is cross and multiply. 130 times 4.448. That's going to give us 578.24. That's 578.24 newtons. Okay, so we need that number. Let's put a little line. We also need to know how tall they're going. So we're going 5 feet. And we know that 3.28 feet is equal to 1 meter. And we're solving for that. So let's work that out. Oh, we got to move over here. We got 5 feet equals 3.28 feet x. So we divide it by 3.28 by 3.28. Our calculator, we're going to divide 5 divided by 3.28 gives us 1.52. So we have 1.52 meters. Okay, so we're going to use those two numbers. Let's put in our work formula. Work equals force times distance. Work equals the force. It's 578.24 times the distance, 1.52 meters. This was newtons. So the work is going to be equal to 879.6. I think it's 5 joules. All right, because joules is equal to Newton meter. So that's how much work Jasmine's doing. Let's go to the next one. Using Jasmine's answer above, calculate how much power she is producing. It takes her 4 seconds. So power is equal to work over time. So P is equal to the 879.65 divided by 4 seconds. All right, and that's going to give us an answer of roughly 219 watts. If yours is 1 or 2 off, that's fine. It has to do with your rounding. So that's how many watts she's producing. All right, let's go to the last one. This one's a little tricky. Ooh. An electric bike is characterized. So what's our gear ratio? Gear ratio is torque out over torque in. All right, don't reverse them. The out goes on the top. So let's figure out torque out first. That's equal to the distance times the force. Now, D means distance, not diameter. So here's our distance. We're going to use that. It's 0.4 meters times the force. Now, what force do we need? Well, we got an 80 kilogram person that we're trying to move. So that's the force. I already converted it for you. So multiply that times 80. And that's going to be our T out. So our T out, multiply that together. Oh, we can't do that yet. We have to convert this to newtons. All right, so we got to convert that to newtons. So 80 kg times 9.8 newtons is going to give us an answer of 784 newtons. So we got to use that. All right, so let's erase that. All right, because force is in newtons, so we'll put 784. And where did I get 9.8? I just knew it. All right, but you can find it on the internet. So that's newtons. Multiply that together, and that's going to give us 314 Newton meters. That's for our torque out. Let's find our torque in. Our torque in is how much power our motor produces. All right. Now, to find the maximum power of a motor, you need the half stall torque. All right, we've talked about that. So maximum power is half stall torque, and our stall torque right here is 40 Newton meters. Or sorry, 400 Newton meters. So it's going to be 200 Newton meters is going to be our torque in. So that's when our motor is running at maximum efficiency, it's producing 200 Newton meters. Okay, it can produce more, but then you start losing power. All right, so we're going to use those two numbers for our gear ratio. So I'm going to rewrite gear ratio down here. GR. All right, our torque out is 314 and our Newton meters. And our torque in is 200 Newton meters. All right, the units cancel out. And if you divide this out, you get 1.56. All right, no units. And that's your gear ratio that you would need on your bicycle. All right, fantastic work.